Well, hello everyone. It's been a while since I've been on the VJug actually, so I'm happy to be here with Thomas. How are you doing, Thomas?
Good. How are you?
Very good, thank you. Just how many DevOps is this for you?
That was actually my first DevOps.
Your first,
here,
really?
So,
in Belgium or first?
First in Belgium. I did a couple of DevOps days in Switzerland, and my first time in Belgium here at the main conference. Very exciting.
Awesome. And this is your first VJug session as well, right? Or is it your second?
I think it's my first
VJug. Your first VJug session. Awesome. So welcome to the VJug. Welcome to DevOps Belgium. So we're here in sunny, rainy, wet and rainy, a little bit cold Antwerp in Belgium for DevOps. It's actually quite an interesting day already because Amazon just announced a really interesting fact that they, well, actually wasn't in the keynote, but it sounds like they're going to be offering free builds of Openjdk, which is going to be interesting, and this is going to be for backporting some of the fixes. So check out the Amazon link for that as well. But we're not going to be talking too much about that today. We're going to be talking about the wonderful new GraalVM, which is I've seen a lot of movement on that in the last 6 months or so. A lot of interesting things that have been happening. So the session today is called Run Programs Faster Everywhere with GraalVM. Just before we get to that, I'll just mention a couple of things. On the Slack channel, if you go to the Virtual Jug Slack, you'll be able to see a link to that from the virtualjug.com website. Questions can be posted in that. I'm actually checking on my phone, so I'll read those questions and pass them straight to Thomas. So make sure you're in the live, live session channel in there. Second thing is, if you're viewing this on the virtualjug.com site or on YouTube, make sure you click the little cog on the bottom right, I think it is, and go to the highest setting you can, so that when we share screens here, you'll be able to see that in the highest res possible. That's pretty much about it. So Thomas, why don't you tell us a little bit about yourself, what you do at Oracle Labs?
I'm a researcher at Oracle Labs. I was I'm there for like 7-8 years now, and during the time we always tried to create like better VM technology, better programming language technology. And so now I'm like leading the GraalVM project there, and we try to like develop a new technology that runs multiple programming languages, a lot of them, and it's not just targeting a single programming language.
Awesome. So let's get started then. If I just quickly share the screen here, then go for it. So share the screen. Do that. Okay. Let's go.
Right. Yes. So I will keep the introductory material at the minimum, and then we will go into a few live demos of some of the latest functionality that we have developed with GraalVM. But just a few slides to give you an intro for somebody who hasn't attended some of our previous talks on it. Generally, as I said, we think it's very important to support multiple programming languages, because the world is polyglot, and this is one of the statistics that shows that. It's from the TOEIC Programming Language Index, where you can see that there is a long tail of programming languages that are used by programmers for their favorite tasks. And what you can see is the most popular language is the language called others. So there's many more interesting languages hiding in there. And that was why in the GraalVM project we started out with one of the main vision of the project was to support a lot of different languages at the same time with the same compiler infrastructure. Because also those languages are very different. You can actually share a lot of core components of the VM, and that gives all of the languages performance benefits and also benefits in terms of being interoperable. One of the later additions to the GraalVM vision is related to security. And in this talk, in one of the demos, I will give one of the demos that shows where we are currently researching more security-related features for GraalVM. And the motivation for that was that, well, programmers like to use all these open source libraries that they are pulling in from various model system websites. But when you pull in that code and run it on your computer, usually you want to run it in a sandbox mode. Because the issue is, like there have been many like security breaches where malicious actors have uploaded code to, for example, the NPM registry or other registry of open source software, and then when you run that on your computer, it could like yeah, it could be bad for you, right? Very recently, actually, just a couple months ago, was a virus in ESLint scope, and so here also a commonly used like module is was kind of infected by a virus, right? And so that's why one of the things in GraalVM we invested more in over the last couple months is to add better sandboxing capabilities, so we can run code not just fast and but also sandboxed in terms of like being secured via the virtual machine and via the compiler. And one of the demos I'll show today is how we can actually run sandbox, not just JavaScript code, for example, but any code on GraalVM, and specifically also native code. So just to summarize the vision for GraalVM, we want high performance and standardized tooling for all languages. That's the core of the project. Then you want this embeddability to be able to run GraalVM in the database in other environments that are currently do not have language execution technology themselves. And finally, we want to have this secured sandbox execution, where we're currently adding more and more features to allow that. So you can run code without actually needing to trust that code. On the project itself, just a quick overview over the languages we currently support. We do support all JVM-based languages like Java, Scala, Groovy, Kotlin, also Closure, for example. Then we support JavaScript. We are up to date with the latest JavaScript standard. You can run JavaScript on the JVM with GraalVM. We support Ruby as one of the languages. We do support the statistical language R. And only recently, about I think about 12 months ago, we added also Python, where we are still a little behind on compatibility, but we are catching up and are investing quite a bit and also getting Python fully compatible with the standard implementations when running on GraalVM. The one part which some people were surprised by is that we can also run native languages. We can also run C, C++, and have that compiled to LLVM bitcode and then run via the GraalVM compiler. This actually adds a lot of new languages to GraalVM and allows for efficient interoperability between those native languages like C, C++, and Java, for example. And then very important for GraalVM is that it cannot only run multiple languages, but it also can run in various embeddings. So one of the embeddings is Openjdk. This is where the Graal compiler is the just-in-time compiler for Java. And in that setup, we are running Java code instead of C2, and you can run any Java application. The second embedding here is in Node.js. We can run embedded in the Node.js platform, but you have a Node.js event loop. But the languages you can run here is not just JavaScript, but again, all GraalVM languages. So you can, for example, mix Node.js with Java or Node.js with Python, for example. But this is where we embed in the core Node.js event loop. We did quite some work to not only embed in these like typical language virtual machines, but also in databases. So there's one demo available for embedding GraalVM in the Oracle database, where it can run stored procedures or user-defined functions. Also, we have a prototype for embedding it into the MySQL database. Because we think that stored procedures and user-defined functions might get a lot more powerful if they are backed up by the language execution technology that would usually run also on the server side. So you can run the same program, the same logic on all parts of your stack without the compromise of performance or anything like that. Finally, you also have the GraalVM standalone deployment, where you are pre-compiling, ahead of time compiling GraalVM into a native executable. And this mode of execution of GraalVM is a very lightweight mode, but uses less memory footprint, and it starts up faster. I will later show a demo also how this can improve the performance, in particular when you're using Java for microservices in the cloud. But in the standalone mode, we are running without any virtual machine assistance, but GraalVM itself is providing all of the facilities of a virtual machine. Generally, GraalVM is a little bit of a hybrid between a static and a dynamic runtime, because you can run any dynamic code, any Java code when GraalVM is executed on top of hotspot. So this is the dynamic setting on the left, where you can run any code, everything can be dynamically loaded. We are fully compatible with Java in that setup. You can run any Java application. On the right, you see the static setup of GraalVM, that we use ahead of time compilation to pre-compile Java code to a native executable. This executable can link with C code or other like object files. There are some limitations on the type of Java code that we can run in that setup at the moment, but we are working to remove those limitations and are looking forward to also make this more compatible with the Java standard. But at the moment, there's some limitations, and this is why native images are still experimental feature of GraalVM. But it can be, like, the reason why it's interesting is that native images provide suddenly an order of magnitude better startup than you would get for a Java application running on a virtual machine. In this setup of where we precompile Java to a native image, you can still run dynamically compiled code as well. For example, JavaScript code, R code, or Ruby code. But this is optional. You can also opt for just having everything precompiled. It's basically your choice which parts of the applications you want to precompile and prepare for fast startup and low footprint, and which other parts of the application you might want to load later dynamically. So the right thing is the native image command in the GraalVM distribution, and the left setup you get when you just use the Java command in the GraalVM image, in the GraalVM binary. So let me just show you now. Let's go to the demos here. So let me show you the first demo, which is just on Java performance. Okay, so let's just go to the first demo of Java performance, and let's go here. I will show you quickly the code that I'm demoing here. It is using Java, and it's using a Java stream expression. So it has an array where it maps. There's a couple maps and then a reduction of the sum. And when I run this type of program now on the standard hotspot JVM, I'm running here now on the standard JVM. It's using the Java micro benchmark harness. And this program can do about 5 operations per microsecond of this stream API expression. And if I run this type of program on GraalVM now, on the latest release candidate, the number of operations per microseconds that you can do goes up to 160. So this is an example where Graal does really well in terms of optimizing stream API expressions. You won't get like a 30x on every program, obviously, but it just shows that there are some optimizations, in particular around removing abstractions of complex Java programs that Graal does a lot better job on. And so one of the things I like to show you quickly here is that Graal also has a visualizer of its compiler graph. And we can use this visualizer to output the compiler graph and to look like what the compilation of this test method looks like with Graal. So what I can do is I can I can specify a command line flag that tells Graal to dump the compiler graph, and I will put like a method filter on that, where I will say I will only want to dump the compiler graph of my benchmark, the test method. I guess I need to swap the command line arguments. How it works. So what we'll see now is that it connected to this ideal graph visualizer and outputted some compiler graph to the ideal graph visualizer tool, which comes with the GraalVM distribution. And what I can do here, I can look at the compiler graph after parsing, for example. Now we can see after parsing on the compiler graph is that still a lot of invocations and a lot of abstractions remain. These are all abstractions from the Stream API. But the good news is that after GraalVM does all its magic and optimizations, in the end, we end up with only a simple for loop that only has the mathematical calculations of the Stream API expression in it. So this just shows like how GraalVM's high-level transformations are very powerful in removing abstractions. And we didn't like create a special thing for Stream API, meaning like any Java framework with similar functional aspects to it will benefit as well from that performance. So this graph visualization is one of the things where we actually, when you test GraalVM, for example, on your program, on your hot method, and you feel the performance is not as good as you would like, we are always very interested to receive compiler graphs of actual programs running with GraalVM so we can improve the performance, because this compiler graph is telling us exactly where the compiler might do even better. So one of the things I quickly want to touch on and here as well is a troubleshooting aspect, because GraalVM is a very new technology. So what will happen if GraalVM compiler messes up, meaning it makes the wrong compilation? So the typical thing that's going to happen here is that there will be a crash of the program, and there will be an error log generated. To demonstrate that, I have here an example program that is producing a crash voluntarily. So it is using like unsafe to access the wrong location. And so what's going to happen if I run this example program with Java is that you will get this little fatal error, and you will also get here an ages error log. And this is the log file that we usually like to see when somebody reports a bug for GraalVM. We'd like people to attach this type of log file. If you look into the log file itself, what you can see is that it has like a stack trace of the program, and it sees how our main program is calling unsafe, and then later it's calling some native code to, and that native code then crashes, but with the unsafe access. So this is the type of stack trace that allows you to actually pinpoint a little bit where the problem might be, or what compiler graph might be interesting to analyze the problem. So this is just to show you in case you run into any issues when running an application, what type of logs there are, and what type of logs we like to see to be reported to Graal. So one of the performance examples that I would like to show here is the complex number example. It's an example that was shown in the Java keynote at Code 1. And I show you here, let's set the Java home here. because I want to run this actually with JDK 11. So I'm running this with JDK 11 here, this example, and it's gonna be Java. Again, a JVM benchmark. And what you can see is that it takes about 800 microseconds per op. Actually, we want to do -prof.gc to also show you, this is one option on JVM where it also profiles the amount of allocations that are happening. So if you run this with a standard JDK 11, this complex number example, while this is running, I can show you the source code as well of this example. So the source code of the example is here. It's doing complex number computation, and it does a matrix multiplication, where in this inner loop it is always allocating new complex numbers. What you can see here then in the final allocation rate of this program is about 3 gigabytes per second. So if you show here, it's 3 gigabytes per second that this program allocates. And so the thing is that even in JDK 11, you can already, with the standard download of the JDK, test a specific version of the Graal compiler by just passing a few more command line flags. So what you need to do here is to do -XX unlock experimental JVM options, -XX enable JVM CI, and -XX use JVM CI compiler, which in our case will be the Graal compiler. Because JVM CI is a generic interface for compilers to hotspot, and Graal is one of the compilers that uses that interface. So what I can do now is I can run this with the JVM CI compiler, and so the warm-up takes a little bit longer, but after we are past the warm-up phase, the performance of this is like more than 2x faster. You can see here it's only 3,500 microseconds per operation, and the original performance up here was about 8,000 microseconds per operation. So just by adding these command line flags to the standard JDK 11 download, you actually get a better performance here with Graal. And you can see actually why, because the allocation rate on the garbage collector goes down a lot. The previous allocation rate was 3,000 megabytes per second, and now the allocation rate with Graal is only 90 megabytes per second on this specific example. And in this example, like basically Graal's escape analysis allows to remove object allocations, and this is then improving the performance by this factor of more than 2. But yeah, so this is just to show you here some peak performance aspect of the Graal compiler. But let's go to another thing, which is the startup performance. So the startup performance, I will show here by showing the native image command and how it's used. I will show here the source code a little bit. I will use here native image of GraalVM to optimize a command line application. And my command line application is called list_dir. It's just going over the files of a directory and outputting the names of the files. It's basically a simple version of ls written in Java. And so what's happening is when I compile this stuff and when I then run this list_dir in usual Java, what's going to happen is that the time to run this command line application is about 200 milliseconds, a little over 20 milliseconds. And that's pretty annoying already for a command line application. So what we can do is we can use the Graal native image command, which is in the Graal bin directory, and we give it the the main class of the Java program, which is list here in this case, and we start running. So this will now do an ahead-of-time compilation of this specific application. It analyzes all of the code that the application uses and then creates a native binary from it. So this native binary can be either directly an executable, or it can also be linked with existing native code. So you can also use it to embed a Java into your native code. After we did that, what we got is like a list here executable that's newly generated here with 7 megabytes. That is our new application that does the list here that I can just call without starting the JVM. And if I now time this application, it runs in like 16 milliseconds, about 10x faster than before, actually more than 10x even. So this is what you can use to run Java faster for command line applications. But you can also use it to run Java faster for microservices. And so for this, what I got is there's one microservice framework that has already put in some support for GraalVM, which is Micronaut. And I got here the Micronaut Hello World, and I have it precompiled. And let me also make this bigger here as well. And what I can do is I can just run Java when it's jar hello world jar, which is packaging my Micronaut microservice framework. And you can see the startup is completed in about 1.5 seconds. Maybe let's try that again. Yeah, 1.1 seconds, but it usually stays above like 1 second. And for microservice, that's actually not too good, right? So what I did before is I created this native image for exactly the same application, compiled with GraalVM. And this application is now, I can show you here, this is this executable, which here is the executable, 48 megabytes. It's everything precompiled here. And what I can do is I can run that executable, and it will start up in here 90 milliseconds, and the second time you have 20 milliseconds. So it's 20 milliseconds, and I got my server running on Micronaut. It can do the first request. It can do actual work. Right? So this startup thing is actually allowing you to reduce memory footprint in the cloud because you don't need to keep idle instances around. Plus, the process itself is also using less memory. So if I'm looking here at the process monitor, and I'm looking at this hello world process, and looking at memory, it takes only 19 megabytes to run this whole microservice framework. On the other hand, if I would start here, this was the standard Java process. It is this one here. It takes like 122 megabytes, 125 megabytes. So you can kind of save memory, and you get a fast startup by using here GraalVM native images. The GraalVM native images, as I mentioned, has still some limitations, so you cannot run every Java program at the moment. But we are gradually removing those limitations, and are happy to work with the community of the various Java microservice frameworks to make GraalVM support those frameworks, so we can get a fast startup, low footprint microservice with Java. So one demo where I will just show you the source code, because I've showed this demo quite a few times, but I show you the source code of just what is possible with GraalVM. It is the Polyglot Demo, where you can run here a Node.js application, and from that Node.js application, you can actually get a Java type, and then use the Java type within your Node.js application. You can not only use Java from Node.js, but you can also use R, for example, or Ruby, or any other GraalVM language. So in this demo here, we were using R to get some graphics that we later output via JavaScript to the browser. But so instead of going into detail into that demo, I will explain a little bit more now about what we do on the security side with sandboxed execution. Sandbox execution of native code. So I will show you here a little program that is using gzip. Let's go to that for a moment. It's on sandbox native. Let's make it smaller here. So sandbox native. I go ahead to a C program that's that is basically a normal gzip, and it has like here it's like all C code here. And it's just gzip in one file. It does a compression. And one of the things we did with that program is that we added a little bit of code to the program to add a bug. Meaning we added code that will produce a buffer overflow in your C code, which is typical. It's a typical C security bug because C doesn't have the bounce checks. So programmers can easily make the mistake of having an API where you can access out of the bounds. And so in this specific example, we access out of the bounds if the file name of what we are zipping is bigger than 10. So first, how can I run this program in general on GraalVM? So for this, I need to use Clang to compile the program. So what I'm doing here is I'm saying clang emit LLVM, which doesn't actually emit the final machine code, but emits LLVM bitcode. I'm using -G because I want debug symbols in my code, and I'm only using 01. In the end, it doesn't matter much which optimization level we're using here, because GraalVM will do its own optimization on the bitcodes anyway. So I can use that and like compile this. And what is generated is a gzip.bitcode file. And this gzip.bitcode file I can now run via GraalVM, because in the GraalVM directory, there is an LLVM interpreter, and I can just run that gzip.bc code. Sorry. So in this case, I'm just running it. I can run it to zip, for example, that small but see, and it shows the file name, and it now created an actual zip of the small.txt file. I think I can do -d. Here, let me just unzip that again. So now it's unzipped, and I can run this with this version of LLVM, of our LLVM bitcode interpreter, which is true to the LLVM semantics. So what I can do now is I will now use my file name is too large file, and let's remove that -d. And what's going to happen actually is here that that the program still executes, but the program was actually now accessing out of bounds. So this is a security violation that in this specific could actually lead to a program crashing. But in this specific case, we are not crashing, but still, like there's something like potentially violating the security of my application, and I actually do not want it to run correctly. So in order to run this now sandbox with Graal, we need to compile LLVM bitcode with a little bit different flags. And I'll just quickly show you what these different flags approximately look like. So this GraalVM sandbox script is a script from us. And when you want to execute sandbox, actually what we do is that we try to link with a generic libc and no specific target platform, because in this managed sandbox mode, we are fully virtualizing the operating system, and so we want to basically have just a neutral compilation of that bitcode file. So that gives us this gzip minus sandbox.bitcode, and I can now run this with our LLVM interpreter. I can say minus LVM.sandbox, and I can run, for example, my gzip minus sandbox on the small file, and it just compresses it, just normal. We can uncompress again. You see that everything was running fine. And if I now use the sandbox version here to and execute the file name is too large, you actually get a correct out-of-bounds access error, including a stack trace on where it happened for your C program. So it prevents the out-of-bounds access, it prevents the security violation, and correctly aborts the program. So this allows to securely execute native code that you do not necessarily need to trust. And we basically support here preventing any type of memory corruption from such a C code. And such corruption can sometimes also lead to corruption of your main managed application. For example, if you have a Java application and you use GNI and C code, and the C code is corrupting the heap, then also your Java application might be crashing. So our safe execution of LLVM bitcode here allows to sandbox this and to remove any type of errors when you're executing your C file. So as the final example here, I'd like to show you a little bit running Graal inside database. And for this, I have here a little bit pre-started an Oracle database on my laptop in a Docker container. And what I have is I have a table, which is a table of tweets. You can here I have like a couple of tweets. So we have an author of the tweet and the content of the tweet. And what I would like to do now is like do a sentiment analysis on these tweets. And so if I go here to node, and in this scenario, I'm executing GraalVM in the database, and GraalVM is executing JavaScript. So I use a JavaScript module, a standard module from NPM that can do sentiment analysis. And I'll show you a little bit on how this looks like here. So I defined a JavaScript function that takes an input. It's called sent. It takes an input, and it does the sentiment analysis from this standard node.js module called sentiment, and it will return a sentiment score of a tweet. And what I can do now is I can now use this send function in my normal SQL query, and then during the SQL query, GraalVM will execute. I will select the sentiment of the content and the content from tweets. I will order by the sentiment descending to get the best sentiment tweets first. And I will fetch first 10 rows only. That's unexpected. It's string length. All right, let's go to another part of the demo where we're using JavaScript model to execute email to do email validation. So for this, I have like a superheroes demo. We have a couple of superheroes table, And what I can do here, hopefully, if it works, here it works. So I'm here selecting, I'm basically using JavaScript to validate whether something is an email address, and I'm using the validator module from npm to run this email address. But yeah, let's just let's see if I can invoke the sentiment here. As here it works. It's telling you the sentiment for these things. So let's just try again. Okay, so now it works. And now, unfortunately, I did the ascending sorting of the sentiment, so we'll get the worst tweets. The 3 worst tweets in this table. The table has about 1.6 million tweets, where we are now iterating over and calculating the sentiment score. Yes, so that's the worst sentiment. I apologize for that. Let me just.
We've had worse.
Yeah, exactly. Let me just get this one more time. As S and the content from tweets. So you want to order by S. I guess you want to order descending and fetch first 3 rows only. All right, so now it seems to work. Yeah, this is about 1.7 million tweets in the table. And for each tweet, we are running the sentiment analysis of specific Node.js module and returning them back. And so, yeah, so now we have a better way to to finish the demo here. We got now the tweets with the best sentiment. And so you might say, like, why do I want to run JavaScript in a database? Good question. Obviously, if you have a certain module that you want to use from JavaScript, that can be interesting. But very important to note here is that we're not just bringing JavaScript to the database. We're bringing any GraalVM language to the database. So this means we also are adding Python support. We recently added a demo with Oracle Apex, running both JavaScript and Python. And generally, GraalVM here enables like one of the execution technologies for data analytics to run stored procedures and user-defined functions in all of the GraalVM languages. So this was the set of live demos. Just to recap a little bit, because it was quite many of them, I guess. We got the Java performance, the Java peak performance demo, where we showed that the peak performance can be very interesting with GraalVM. We showed the Java footprint and memory advantages for using GraalVM from Java microservices. I then quickly showed the Polyglot Node.js program, and then later the sandboxed execution of C code, and finally GraalVM running in the database Node.js models. So as you can see also from this set of demos, they are quite diverse, use different languages and everything, because GraalVM is really, like, there's a lot of different things you can do with it. And you have this one blog post that's called Top 10 Things to Do with GraalVM. I really recommend to look at it, because there might be one application scenario that is really interesting for your use case. So to continue here, this is actually the output from this Polyglot demo that I didn't show here live. But you basically have your JavaScript mixed with Java and R to display stuff. So under secured sandbox execution, I give the demo, so we can do managed execution of native code. We can actually also execute sandbox. We can do time boxing to avoid denial of service attacks, memory boxing with a similar aim. And in general, our language implementations themselves actually do not need to be trusted, because they are themselves like executed in a managed way. So this is very important for us. So we have a small surface or attack area on GraalVM. So in terms of long-term trends that we think that will benefit actually GraalVM and help it along its vision is that, well, data obviously increases faster than bandwidth. So this actually allows you, means that it's usually more efficient to send the code to the data than the other way around. And their GraalVM can help you execute a certain piece of code, for example, in the database to pre-filter and then avoid actually sending all the data over the network, which is quite costly. It's one of the most expensive things in the cloud, actually, to send data around. Well, languages in use are diverse and change fast, and with GraalVM, we embrace that because we are supporting multiple languages, and we think there's a place for multiple languages in this world. So we really like to be able to execute all of them efficiently and bring them together also to make it interoperable. So you don't need to rewrite everything from scratch when you change from one language to another, but you can actually reuse libraries that you've written or invested in before, but still use parts of your program, another programming language to do part of your programming stack. Well, another long-term trend, and this is actually continuing quite a bit, is that more and more of the software stack is based on external code. So there's all these very rich open source ecosystems out there that are very beneficial for you to use. But one of the things to keep in mind here is that you likely want to use them in a sandboxed way, because when you throw in these dependencies, usually you throw in like millions of lines of code, sometimes even, and in these scenarios, you want to be sure that you don't need to vet that code, because you're not going to look at all of your dependencies code, but you want to run it in a sandbox mode, so you don't actually care about whether they are compromised or not, because they cannot break out of that sandbox. Well, developer costs are increasing, so developer productivity is more relevant. And this is another aspect here where you can, where GraalVM enables developers to really choose the right tool for the right job. So they can choose the right language to a specific job, and this allows them actually to be more productive. And generally, GraalVM is a big ecosystem, and that's a multiplicative value add of that ecosystem. Meaning, like, you can use those languages in the embeddings, and there's the thing in the middle is kind of the language agnostic functionalities that we provide, including tooling and optimization that are helping actually make the overall ecosystem richer, and allow you then to use also for example, if you have a domain specific language where you want to run it on GraalVM, you get all of the optimizations, tooling, and interoperability for free. So we have actually some companies currently evaluating moving their implementations of the languages on top of GraalVM. Most recently at Code One, Goldman Sachs gave one presentation about their proprietary risk management software that they have a specific programming language there, and they're currently evaluating to move that programming languages also on top of the GraalVM platform to benefit from the performance, from the tooling, from the security aspects that you get when you hook into that platform. So really feel very welcome to add your own language or your own embedding, or also to add language agnostic tools to GraalVM, because what you can do with GraalVM as well is to add a tool that is language agnostic, meaning if you have a profiler, for example, it would work across all GraalVM languages. We did a lot of work in the project. Maybe the main component is to sort of develop these common interfaces between the programming languages, so you can talk to a programming language without having to directly depend on it. Well, is it production ready? Well, we currently have release candidates out there for GraalVM, but some companies, including Twitter, are already using some parts of Graal in production. So in Twitter specifically, they are using it to speed up their tweet service that runs on finite length Scala code. Generally, actually, for Scala code, our performance is specifically good. So if you're running a Scala application, I would definitely encourage you to test GraalVM and whether it gives you more performance, more peak performance specifically. And generally, this actually testing Graal in the application is very easy, because we are compatible with Java here. So you just set a different Java home, and then you can test the application with GraalVM. And it shouldn't take you long. And we are happy to also look for feedback on our GitHub issues and similar about your experiences of running Graal on your workloads. Because as developers of such a platform, we actually very much dependent on real-world users out there testing it and giving us feedback on the actual workloads they care about. As opposed, because otherwise we just have to like work with some benchmarks which might not actually reflect what people care about in the actual deployments. So please really feel free to reach out to us and give us feedback on running GraalVM for your application, or also on like what you think would be a use case for GraalVM in your world, in your setup, where you could benefit from it the most. Because we're using this community feedback to define further development directions and to prioritize what we're gonna like support better in the next releases. GraalVM as a big community, has a lot of people work at Oracle working at GraalVM, but you also get contributions from the outside. We have a website. You just go there. There's documentation. There is downloads of the latest bits. It is open source. GraalVM you can find on GitHub. You have a GraalVM Community Edition that is fully open source and free to use in production. We also have a GraalVM Enterprise Edition where you need a license if you want to use it in production. But generally, also on GitHub, check out the source code. There's like a couple million lines of code actually online. A couple million lines of open source code that we maintain on GitHub for GraalVM. Not just the Graal, this is the core repository, but also repositories for some of the GraalVM languages like the JavaScript implementation, the Ruby implementation, the R implementation. And feel free to also basically post issues on those GitHub pages if you run into problems trying it, or if you have some comments or want to start a discussion on a certain topic related to GraalVM. And with that, I'm at the end of my presentation. I hope you found it useful, and please feel free to give me feedback on the presentation. Also via, for example, Twitter, like direct messages. I'm very happy to hear from you as like what you found interesting on the presentation, what type of demo you would expect to be more sophisticated or different, or generally feedback on GraalVM itself. So really feel free to feel encouraged to reach out to us and give us feedback on any parts of the platform. And so far, thanks for listening to that presentation.
Awesome. So yeah, please note down the Twitter handles to follow there. There's GraalVM and there's Thomas Wu.
Yes.
Wu. Okay, and while you're taking that down, we'll jump to Q&A. So I've got some Q&A which has been building up in the Twitter stream right now. So that should be enough for people to grab that. So I'm going to grab the.
I'm going to go to
Hangouts. There we go. So what we'll do is we'll stop sharing here. This should hopefully. There we go. Right. So yeah, I've got some questions here. We can do one or two things. So for those of you who don't know, I'm sure you probably do, Oleg Shalayev is also actually one of the advocates for Graal, also working on Oracle Labs. He used to work with me, obviously, at Zero Turnaround. So I used to be his previous manager. You're now his current manager. So we could either do a live performance review and compare and contrast, or we can go to questions on the. So what would you prefer?
I don't know. I think he's nearby, so I would prefer to go to the questions
first. He's not listening, so maybe we could do a quick 5-minute. Let's go to questions. Okay. So we've got a couple of general questions, and obviously, feel free to either reach out to Thomas or Oleg in future beyond this session. So a couple of questions. One which Oleg's already reacted to, but it's worth asking this question for the video replays as well. So Graal is currently not available on downloads. Oleg responded
on Windows. Yes. So the Windows support. Yes, I can say a little bit on that. So we actually have on OTN, we have a Windows version, but the Windows version doesn't support native image at the moment. So generally Graal as a compiler works on Windows. That's not the problem. We just have still some issues with producing the native images. But we are actively working on that, and we are basically expecting by the end of the year, maybe it slips early next year, but we are actively working on like getting Windows support for all of the things in GraalVM, which includes then also native image.
Awesome. Michael Vala asks a question about how to decide whether to use Graal or Openjdk or Node, for example, or something else. So to summarize, what would you say are the big talking points in terms of the differentiators really for Graal?
Right. So I mean, it depends on which deployment, right? So Graal for a Java application, for example, I think you definitely try it because we have a different compiler. So it's likely that you will see a performance difference to Openjdk. Sometimes you're faster. There can also be still some regressions, and then you're still an experimental technology. But generally, in particular for complex Java code, or Scala code specifically, we have gotten very, very good results. And that's why Twitter, for example, is using Graal and not the other compilers in Openjdk because they got so good performance results, right? Versus Node.js, it's more about when you want to use Intop, for example. If you want to use other languages from your Node.js application, then that's interesting. And we are also looking, which is not in production right now, but we're developing more security-related features for Node.js, for example.
Okay, let's jump to this one here. Nikolai asks, what's the difference between the open source GraalVM and the commercial version?
So the difference is it's a performance difference. So it's functionally the same. So you can any application that runs on the open version can run on the closed version and the other way around. This is very important for us that we put everything that is everything that is functional also in the open version. But you will notice a difference in terms of Java peak performance, and you will notice a difference also in terms of further reduction of memory on native image. So that being said, it's like in many scenarios actually, even the open source version that is out there is giving you an advantage, in particular for Scala code. Like Twitter, for example, is using our open version out there, and they're doing that because it gives them an advantage. So generally, we feel like, well, we wanna make sure that developers have a very good time like developing this GraalVM, but you also want to make sure that if your company is like a big cloud deployment and paying lots of money to Amazon for that, and then we help them reduce the Amazon bill by 20% because we run the Java 20% faster, then we kind of we appreciate if you give something back to the project to help maintain it and to help actually further improve the performance rate. Because in the cloud, and also as Chris Starlinger from Twitter often was saying, is like in the cloud, performance translates to real dollars, right? And I feel we're actually wasting computational resources at the moment because we could actually invest more in getting faster compilers, and this will reduce actually your cloud bill.
Awesome. So Duke, who's often asking questions about ARM support, I'm guessing he does a lot of work with Raspberry Pis, asks if GraalVM can run Java 9 plus on ARM version 632-bit architecture, which is the Raspberry Pi. Now Oracle's dropped the ARM support or I guess it stopped producing ARM builds, right? In
right. So we like ARM. Also because like the native image specifically is very suitable to run on a small device because you don't have a JIT compiler, you're saving on memory actually, right? So we can actually, I mean, Raspberry Pi is one device, but we actually try to then target even lower end devices where you really maybe have only like 32 megabytes or 16 megabytes of RAM. And that's why for native image specifically, we are currently actively working on an ARM port of native image because it's one of the like we got a lot of help from Red Hat, thankfully. Should I say IBM now? but Red Hat, we actually hope that IBM is continuing that help. But we got a lot of help from Red Hat on getting the ARM port for GraalVM started, and they contribute quite a bit there. So Graal itself supports ARM architecture, but native image again doesn't support it yet. But we will try to get it done also as soon as possible. We got some help as well from John Voss, who does a lot of things related to Openjdk and mobility. And we're absolutely happy to work with the community to make sure that GraalVM works very well on ARM.
And do you provide the binaries for that?
At the moment, we do not provide the binaries, but we will as soon as it's stable enough.
Okay.
At the moment, it's not stable enough and not tested enough. We do have internal test infrastructure already set up for ARM, because we also think ARM could also be a player even in the server space, right? I mean, it's not just the small devices nowadays; it's also when they try to do a server. There's a couple of startups that do like Ampere, for example, who develop new ARM servers for server-side workloads, and we actually really want to support that. So you can run a low-cost microservice on ARM with GraalVM.
Okay, we're actually because we're actually on the Vox booth. We're gonna have to make way for others. We've got a couple more questions from Nikoski and Sergio, but I suggest we take that over on Slack afterwards. So yeah, thank you very much, Thomas. Appreciate your time, and again, very much welcomed by the VJug audience as well. So do be sure to follow the GraalVM and also Thomas on Twitter, and the best website to go to graal.org.
GraalVM.org.
GraalVM.org. There we go. Don't go to graal.org. I have no idea what's there. So GraalVM.org. Thank you very much. Enjoy the rest of Devox, and see you next time on the virtual chat.
Excellent. Thanks, Simon. Thank you.